Okay, so here we're going to be working with Hess's law direct method. Um, and the way we start this problem is we have to write down the equation that we're going to be using. So the question here is asking us what is the delta H of reaction for the following reaction given, and then it gives you the heats of formation of methane, which is CH4, carbon dioxide, and water, right? So what we do is we have to write our equation first. So delta H of reaction, like anything, is final minus initial, all right? So what you can think about here is if we're making pancakes, we start off with pancake batter and water, right? So our pancake batter, which comes in this little box here, let me just draw a box. So it comes with that little box, and you add water, and you form pancakes, right? Well, pancakes are a product, correct? And the pancake batter and the water are reactants. So we initially start with pancake batter and water. So this is initial, and over here will be final. So the change of anything is final minus initial, correct? So we're going to say here that the delta H of formation of our products minus delta H of formation of our reactants is going to be equal to our change in delta H for our entire reaction. All right. So that's the logic you could use to think about that if you forget the equation on the exam. So let's go and get to it. Okay, so these actually should be in kilojoules per mole. I don't know why they didn't have that on the problem. All right. So what we do here is we start off with our products. Okay, so these are our products, correct? And we have carbon dioxide, and we have to look how many moles of carbon dioxide do we have in this reaction. So the little ingredient or the recipe here calls for 1 mole of carbon dioxide to be produced. So we know that we don't have to multiply carbon dioxide by anything, so we're just going to leave it like that. So negative 393.5 kilojoules over mole, and that's going to be times 1 mole, right? 1 mole of CO2. And that's going to be added to 2 moles of water, right? So 2 moles of H2O multiplied by the heat formation of water. So negative 285.5 kilojoules per mole, right? And let's go and put that in brackets. And that's going to be subtracting. So we're going to do minus, and let's go to write our methane. So let's go start another bracket. Okay, so methane. How many moles of methane do we call for? Well, you see over here, there's an imaginary 1. So let's just go ahead and write 1 mole of CH4. And we're going to multiply that by the heat of formation of 1 mole of methane. So 74.8, negative 74.8 kilojoules per mole. All right. So now, what do we do with oxygen here? If you notice, they don't give us a delta H of formation for oxygen. And the reason for that is that anything that's elemental, so for example, okay, so let me write this over here. Anything elemental, such as H2, O2, S, C, F2, Cl2, um, phosphorus, anything that's by itself is elemental is going to have a delta H of formation of 0. Delta H formation equals 0, right? So in this case, we don't have to consider oxygen because it's going to contribute 0 to the delta H of formation of this entire reaction, all right? So we know all the reactants, the delta H of the reactants is going to be equal to the delta H of methane. So we're just going to leave this like this. Right, and if you notice here, moles cancel out all the way through. So the units that we should be left with is kilojoules, which is exactly what we want to be in. All right. So if you plug this into your calculator, let's go and do this one step at a time. So negative 393.5 times 1 equals negative 393.5, right? Okay. And we're going to be adding that to 2 times negative 285.5. and I get from that negative 964.5 kilojoules, right? And we're going to be subtracting, uh, and we're just going to carry down this negative 74.8 because it only multiplied by 1 and we didn't do anything else to it, right? So a minus minus a minus is the same thing as doing a positive plus a positive, right? So let's go ahead and add the 74.8, and once we do that, we get negative 889.7 kilojoules, right? And that should be your final answer. And the direct method is actually the easiest one. There's also a way to do this. Uh, for the indirect method, there's a similar way to do this. I don't want to get too much into it because it really confused some of my students. So um, yeah, that's the direct method. I hope this video was useful to you, and thanks for watching.